So we're doing projectile motion. A skateboarder is slowing down at a rate of 0.70 meters per second squared. So first things first, we need to write our givens. The acceleration in the X direction is what I'm going to call it. And then this is for the skateboard. Is equal to 0.70 meters per second squared. Now, he's not speeding up, he's slowing down. So what direction would that? That's right. So it goes in the negative direction. At the moment, he is moving forward at 1.5 meters per second. So that means my velocity in the X direction for the skateboard again is at 1.5 meters per second. Well, because I'm going to read the whole problem, and I'm going to figure out he's going to throw something up, and I'm going to call that Y. Okay, so he throws the basketball upward so that it reaches a height of 3.0 meters. That means my maximum height 3.0 meters, and it went up, so that's a positive. And then he catches it at the same level. So that means the total delta Y is equal to 0 meters, because it went up 3, but it came back down 3. He didn't catch it below, he didn't catch it above, he caught it at the exact same level. So the total change in displacement in the Y direction is going to be 0. Total. Stands for total. Y max. Y max. Okay. It says, determine the vertical and horizontal components of the ball's velocity relative to the skateboard when the ball left his hand. So the unknowns that we have are Vx initial and V initial Y. Both of these are for the basketball, or just the ball, whatever you want to call it, right? I'm going to say ball because I don't have to use it much. Okay, so we need Vx and VIY of the ball. Vix and VIY for the ball. So, I always tell y'all to draw a picture. So what I'm going to do is I'm going to draw a picture. We got a nice little skateboard right here, guys. Look at this. And he's got a ball. Why he's on the skateboard with a basketball, I don't know. Maybe he's playing skateboard basketball. But he is going to throw this ball. And right here, we're going to have our Y max is 3.0 meters. This angle that he launches it at is what? Did it say? It's unknown. So I don't actually need to put it. I'm going to say this is my initial. I'm going to use this one as my final point for my first solving. You'll see in a second one. Okay, so Y max is 3 meters. I don't know what my X is. Maybe I'll call this point 1. That'll work. Initial, this is point 1. And this is down here, my final. You like that better? Alright, so this is delta X, which is unknown. One thing we do know is that he is moving this way with a velocity of 1.5 meters per second. But he's got an acceleration going this way of 0.70 meters per second squared. Right? Okay, So I've got to make a plan on how I'm going to solve this problem. Now I told you that y max is going to be up here at this point, which I called point 1, right? What do I know about y max? It's my maximum height. When does it occur? At the center of the total thing, which means it's going to be at what time? Half of the total time, right? So I need to know that. So if this is time equals 0, over here is t equals whatever it is, right? Whole delta t. Right here, t is equal to 1/2 of delta t. I think I have described this problem now. How about the ball itself? What can I say about its acceleration once it's thrown? Can I think of an acceleration for this ball? A for the ball, so AY for the ball, actually, is equal to negative 9.8 meters per second squared. What about AX for the ball? It's 0. So, the acceleration of the skateboard is 0.7 to the left, but the acceleration of the ball is 0 once it's left, right? So that's where this problem became a little bit tricky, but it's not that bad. Okay, using what I'm given and what I've got unknown, the first thing I am going to solve for is VIY. I'm going to use an equation using the givens that I have and the unknowns. So, the acceleration in the, well, I got to pick my equation, I guess. I'm going to use A is equal to V final squared minus V initial squared over 2 delta V. I'm going to solve this in the y direction. I'm going to solve it for when y max equals 3. So that means my delta y is 3. What else does that mean? What velocity am I moving at my maximum height in the y direction? At the maximum height, what velocity am I moving in the y direction? 0. V at point 1 that I put up on my drawing is equal to 0 meters per second. It's not moving. Okay? So, then go down and we can start solving this equation. Acceleration in the y direction is always what? On Earth. Negative 9.8. V final squared, we just said, is going to be at V of 0.1, which is going to be 0 squared minus the initial squared, which we don't know. That's what we're calculating, right? And this is in the y direction. All divided by 2 times our delta y, which we said at that point is going to be 3 meters. Okay? So the first thing I need to do is I need to try to get VIY by itself. I'm going to multiply each side by 2 times 3. I'm going to multiply this side by 2 times 3. Right? So 6 times negative 9.8, what do I get? Well, I bet you I get negative 58.8. That is equal to VIY squared. So now what do I need to do to get y or VIY by itself? We got a negative sign. Well, I need to divide by a -1 because taking square roots of negative numbers is bad, right? So that now have 58.8 is equal to VIY squared. Well, I had a -1 multiplying times both. I wanted VIY by itself, right? Okay. So Now I'm going to take the square root of both sides. Square root of 58.8 is what? Your calculator should tell you that it's about 7.7 meters per second. And that is going to be my V initial in the Y direction. That was one of the things I was looking for. That's good, right? What's your question? How do I know which formula to use? I looked for a formula off of my formula chart that had things that I have and the one thing I'm looking for. I had A for the Y direction. I had V final for the Y direction. I had delta D. The only thing missing was VI, and that's what I needed. So I looked for an equation that only has one piece of information that I don't have. Okay? So that gave me 7.7 meters per second. That's VIY. We're not done yet, though. We still need to get VIX, and that's going to take a little bit more work. That's the skateboard with 1.5. The ball is different, because the ball is not going to decelerate. If he catches it on the skateboard, the ball had to be moving at a different speed, because his skateboard is still decelerating. Okay? So the next thing I decided to do was I wanted to solve for time. Time's always good to have in one of these projectile problems, right? So I'm going to go and I'm going to solve for the easiest time that I can. Since I know V initial now, I can use the equation A is equal to V final minus V initial over delta T. So A in the Y direction, so I'm going to do this in the Y direction for delta T. Go to solve it. A in the Y direction is what? Negative 9.8. That's going to equal my V final, which we said was 0 minus the V initial in the Y direction, which was 7.7. We just calculated it. All divided by delta T. So we go through the steps to solve this. I multiply by delta T on both sides, and then I divide by negative 9.8, and I'll get delta T is equal to negative 7.7 divided by negative 9.8. I put that into my calculator, and I should get delta T is equal to 0.786 seconds. Now, this is delta T only going to where we got the max height. That's how we got to use that 0, right? Right? Okay. So what I need to do is then double this time, right? Because we said max height would be at half the time, right? So delta T, we're going to plug this in. So delta T for the total time is going to equal 2 times delta T. We wrote that up on our diagram. So 2 times 0.786 is going to be 1.57 seconds. Okay? We're almost done. 2 more equations. Like I said, this was the most hard question we had on this whole entire sheet. Okay? Now I'm going to try to find the displacement of the skateboard. Because if he caught it, I need to know how far away it was, right? So we're going to use values from the skateboard, and we're going to use our displacement equation. Delta D is equal to V initial delta T plus 1/2 A delta T squared. So this is all skateboard in X, right? Skateboard in the X direction. Okay. So delta D is equal to V initial I delta T plus 1/2 A delta T squared. Skateboard in the X direction. So delta D is the unknown, or the delta X, right? Equals the initial velocity of the skateboard, which was 1.5, times delta T, which we know is 1.57, plus 1/2 times A in the X direction. This time is what? For the skateboard.
Teacher, the student, pardon this interruption.
All right, so negative 0.70 meters per second squared times delta T, which is 1.57, and we square the 1.57. So we plug this into our calculator, and we'll get delta X is equal to 1.49 meters. All right, so that's how far the skateboard traveled, right? One more little piece and we're done. We're going to solve the same equation, but this time we're going to use the ball. So it's going to be the same equation as we used before, but this one, it's going to be for the ball. Okay? So delta X, we know this time. The ball traveled the same distance in the X direction, didn't it? Otherwise, he wouldn't have caught it. So we have 1.49 is equal to the V initial in the X direction, which we don't know, times time, which was 1.57, plus 1/2 times what's the acceleration of the ball in the X direction? The ball is a projectile. It's left his hands. He's not accelerating anymore, or the ball isn't accelerating in the X direction, right? So it's going to be 0 for the acceleration times 1.57 squared. All right, so this whole term becomes 0 because we used a 0, right? So all I need to do is divide by 1.57, and I get that my V initial in the X direction is going to equal 0.95 meters per second. Whew.